pleasure to be here. I see a lot of familiar faces and a lot of new faces. This is a great group. I really appreciate the Fishers and Farmers Partnership pulling this together, the Water Resource Center here at Minnesota State University. They do great work, and I'm really honored to be here to kick this off. What I'd like to do over the next 30 minutes or so is give you a little bit of context, a little bit of background about the broader picture here, talk a little bit more specifically about ravines, what they are, a little bit of what we have learned about them over the last couple of years. And then we'll turn it over to Marty Melcher, who's going to be next, and talk about ravine stabilization and management. I'm going to walk around a little bit, and I would encourage you guys to ask questions as I'm going through this. I'm happy to pause for a moment if there's something that's not clear. And tell me if I'm talking too loud or too soft. I don't use a microphone much. I just yell to my classes, so hopefully this will work all right. I want to point out as I'm getting started here, Karen Gran is at University of Minnesota Duluth, and she is a close collaborator of mine. She's done a lot of the research on ravines that I'll present today. So I'll point her out here, and a number of other folks that contributed to this. Okay. I'll start out just saying that nobody wants to see a muddy river. I think we're all on the same page there. People want healthy water. People want healthy land. And that's the basic premise that binds us all together, and I'm sure a big part of why you guys showed up here today. Nobody wants to see this. And we know this doesn't happen often, but it does happen sometimes. And the key part of today is nobody wants to see this. This is the Blue Earth River here. This is a ravine coming down. It's been destabilized up by the head, and somebody's about to start losing a lot of land. Today is all about making sure that doesn't happen, and figuring out other ways we can reduce sediment inputs from ravines, use ravines to reduce sediment inputs in the river channel. This is another animation here. I've got a couple of air photos starting back at 1991. You can see this bluff here. This is an ag field right up here. As we march forward in time from 1991 to 2003, 2008, 2009, it's not looking too bad. If you remember, there was a big flood in 2010. And since that time, we've lost a lot of land. Nobody wants to see that. We're all on the same page there. This is September of 2011. So how do we make that not happen? There are a lot of sediment nutrient problems in Minnesota. I think I see things trending in the right direction. You all know very well where we're situated right here, the Minnesota River Basin. I've done a lot of work in the Le Sueur River Basin. The Minnesota River has 336 impairments, says the MPCA counts them. We can agree or disagree about how the MPCA identifies impaired waters, things like that. That's a good conversation to have, but I think we're all in agreement that there are some problems that could be dealt with. And it's also the primary source of sediment and nutrients for Lake Pepin. And many of you may have already seen this graph here. These are sedimentation rates in Lake Pepin. And if you look, this is the year here. Early on, going back to the year 1500, sedimentation rates are pretty low. They've gone up considerably since that time. And they've maintained relatively high rates over the last 4 or 5 decades. And so people saw that and said, well, why are we putting so much money into conservation? It doesn't seem to be doing any good. And one of the things that my group has shown in collaboration with a number of other groups that have been working on this problem is we are making progress. That agricultural erosion has declined, but we're not seeing any effects in the river right now because at the same time near channel sources have been amplified. We're increasing erosion rates in near channel sources of sediment, bluffs and banks and things like that, ravines. So that's what these geochemical data that are the points here, I won't get into the details of that, but that's what that showed us, is that the source of the sediment has shifted. And so that means we have to change the way that we manage things and the types of tools we use to further reduce sediment loading. So the big questions are, where is that sediment coming from? How much of that's human versus natural? We can go on and on about that, but we can also identify some things we can do to clean the river up. And the important thing is we're doing things that will really help. There's no question that water quality, aquatic organisms, and recreational value have been degraded. This is showing species richness of mussels, fish, and macroinvertebrates, bugs, which is the food for fish. And those have all declined over time. Top quality fish species have declined. This is a plot of a global compilation showing rivers all over the world, and for different drainage areas, what kind of bug population you should expect to see there. And the surprising thing that came out of this is that the Minnesota River plots way down here, well below where it should be up here. About 10 to 100 times lower than it should be. And the question is why? Why isn't the Minnesota River being as productive for bugs, which also makes it less productive for fish? And how can we turn that around? These are the big questions that we're talking about investing money to improve, and we need to make sure that we get the answers right. Minnesota spends a lot of money already. These are numbers of acres that have gone into conservation easements in the Minnesota River Basin, put a whole lot of land in conservation easements. These are the number of sediment and nutrient management projects from 1997 to 2008. There's a whole lot of dots on that map. Minnesota's really been investing heavily in trying to improve these issues. There's a legacy amendment that's going to bring a whole bunch more money to this. And regardless of what you think about the legacy amendment, whether you agree with it or disagree with it, I think everybody's on the same page that if we're going to spend that money, we better make sure we're spending it in the right places and we're fixing the problems and we're getting good bang for the buck. Getting a little bit of feedback here, but stay away from that spot. The cause of the problem seems obvious, but it depends on who you're talking to as to what the obvious answer is. Some people say, well, the answer is obvious. There's too much sediment in the river, it's all ag land, it's got to be the farmers. Other people say, well, we've got all these big bluffs, the answer is obvious, it's coming out of the bluffs. And other people say, well, we've got all these ravines that are ripping up the land, the answer is obvious. And as it turns out, the answer is not all that obvious. And it's a combination of all these things. If you go back 50 years ago, there was a lot of sediment coming off farm fields. And farmers have made progress reducing soil erosion, considerable progress. But like I said before, at the same time of increased flows in the river, we're amplifying erosion of all these near channel sources. So as it turns out, these are complex systems. Rivers and watersheds are complex, and we can't fall into the trap of the answer is obvious, we know everything we need to know. It's also getting quite a bit wetter here. This is, I think, the most difficult plot that I'll show here. Basically, this is a student from University of Minnesota that did this. She pulled all the precipitation records in these two time periods, 1948 to 1977, 1977 to 2011, and then just organized them from biggest rain event to smallest rain event. So the biggest rain events are over here, all the way up to the smallest one. So every single rain event during those time periods is represented on those lines. And what we see is that the really big events have gotten a lot bigger. It really is raining more here. And the cause for this, well, we can talk about that later, but there's no question we're getting more rain. We're also draining the landscape a lot quicker than it has been in the past. And we're seeing, these are 7 different stream flow metrics. mean annual flow, peak flows in the spring versus the summer and fall, low flows in the summer versus the winter, the number of high flow days and extreme flow days. If you look back from about the 40s to about the mid-80s, there was variability in there. Nature's highly variable, but the average is more or less the same. But over these last couple of decades, things have really increased quite a bit. All these stream flow metrics have gone up, and they're developing this interesting cyclicity to them. And so there are some big things going on in Minnesota in terms of precipitation and stream flow. And this all has impacts for what happens on the land, and it all has impacts on what happens in the rivers. That's what I'm getting to here. Drainage is part of the reason that those flows have gone up. Now there are upsides to drainage. Productivity is way up. This is an image that was just released from NASA last week, the NASA Goddard Space Flight Center. It's an infrared image showing plant productivity. And you can see the Corn Belt shows up really well here. This is an incredibly productive place, and it needs to remain an incredibly productive place. And I think everybody's on the same page there. The other upside of drainage is that more rainfall infiltrates in the soil, and therefore you have less surface runoff. There's less water running off the surface, that means there's less soil running off the surface. Part of the reason that we're seeing less soil erosion is probably because of the drainage that's gone in. And that's something that has been kind of controversial and discussed a lot over the last couple of years, but I think people are in agreement on that point now. You guys are well aware of the downsides of drainage as well. You've seen it in your backyards, no doubt. We're concentrating flow in some sensitive areas, and what I'm going to talk about next is that there are some really sensitive areas here in Minnesota, particularly in the Minnesota River Basin, and that can do a lot of damage. Here's a ravine that I showed earlier on the Blue Earth River. It's been destabilized. We're also increasing flows in the river, and that destabilizes bluffs and things downstream. And so we need to be thinking about that. My group, funded through the MPCA and National Science Foundation, put together a sediment budget for the Le Sueur River. So between the time period 2000 and 2010, we figured out where all the sediment was coming from. We used a lot of different tools and techniques to figure out where the sediment was coming from. But the short part of the story is that the dominant portion of it's coming out of the bluffs. And those bluffs are eroding a lot more now than they ever have in the past because of the increased flows. Ravines are a relatively small part of the picture. The numbers are metric tons of sediment coming out of each of these sources. The total amount on average per year is 225,000 metric tons. But ravines are a relatively small part of that sediment budget. But they are part of it, and there are hot spots that are particularly problematic. Ravines generally contribute only about 2 to 15% of the total sediment load. They're a little bit worse in wet years because we're concentrating more flow there. They're a little bit better in dry years. When you're dealing with mud and trying to figure out where mud's coming from in the landscape, it's a tricky business. And there's a reason why we've got decades and decades of science that has made little progress up to this point. So one way to think about these things, beyond the sediment budget we've put out, is to say when the ravines are flowing, if they were contributing all the sediment, how much sediment would that be? And that would end up being just 3 to 21%. And so ravines are a small player. We know that from a lot of different sources. But again, the hot spots are what we really want to identify, and we want to see if we can use them to reduce the flows and reduce some of the problems downstream. And that's a lot of what we'll talk about today. One last kind of general point before I start talking about ravines specifically is that this is a really special landscape. There's a number of reasons I'd love to come back here. Working and living in Utah, I spend probably 2.5 months out of the year here in Minnesota. In part because this is a really fascinating landscape, also great people, I've never been denied land access. Anytime I need to get to a place, people are always welcoming. I'm in much bigger danger of talking with people about what's going on the land than I am getting denied land access here. And that's a nice problem to have. This is a really special landscape though, and I want to just give you a really brief explanation of why it's a special and really sensitive landscape. 13,000 years ago, well, 15,000 years ago, there was an ice sheet here that was about 1.5 miles tall. 1.5 miles of ice that went clear up into the Arctic. That's a lot of ice. That retreated, that laid a lot of the soil down here. 13,400 years ago, there's a massive lake just to the north of here, covered a good portion of Canada, and that catastrophically drained through the Minnesota River at that time. And this is that lake, Glacial Lake Agassiz. It breached what was a little moraine here, and some dirt that had pushed up, holding it back, and just catastrophically drained through here. Huge torrent of water. Incised the Minnesota River Valley, really created the Minnesota River Valley, incised it by over 200 feet. And so all, the main stem Minnesota River cuts down, all of its tributaries now are left hanging there. And they've been some of the fastest incising rivers in the world. And that's something I didn't appreciate when I came up here 7 or 8 years ago. But it really is an important part of how this system works now. It's a really naturally, rapidly eroding landscape. And that's one of the reasons it's really sensitive. This is a photo I grabbed just as I was taking off from MSP Airport. You can see this big causeway that was created from this event 13,000 years ago. These are all the river profiles. So if you look at the elevation of the river as you go all the way downstream, that's what this graph is. Distance to the mouth of the Minnesota River in elevation. This is the main stem Minnesota in black here. It's scoured out. It's a pretty low gradient river. And then all the tributaries coming in have these really steep nick zones right towards the bottom. Those are the really sensitive parts of the river. So geologists, there's only 2 types of geologists. There's lumpers and there's splitters. Lumpers like to group things together and make things simple classes. Splitters like to, parse things up into 1,000 different classes. I'm a lumper. And I'd say there's 3 main parts of this landscape. And this is important for how we think about where the ravines are and where we might need to be doing different things in the ravines to manage them or to use them to manage the water better. The 3 main parts of this landscape are in brown here, the uplands. Relatively flat, very flat by Utah standards. These are very passive rivers that are flowing up here. They don't move around a whole lot. Then you get into the green area here, I'm calling the nick zones, and these are the really rapidly incising zones. These are hyperdynamic rivers. We don't have anything in Utah that can come close to how dynamic the rivers are in this part of the Minnesota River Basin. These rivers are moving around a lot. They're very active. Then you get into the main stem Minnesota River Valley that was scoured out 13,000 years ago, and that's a grading, and it's very active in very different ways. So these are different parts of the river that I think about a lot in terms of how they respond when we start changing flow, when we start changing sediment loading, things like that. They're all going to respond very differently. Okay. Any questions there? I know some of you folks have heard that story before. Dave Craig Miles heard that story so many times he's probably going to recite it in his sleep. Or any other comments about the landscape in general? Yes?
When Florida County put in County Road 90 bridge across the Florida, they blocked the channel of the river and they left it that way over winter. And as a result of it, it washed out all of the bank right into the right of way on the other side.
Yep. This is a big issue we have to deal with here is we've got all this infrastructure right around the rivers. And rivers want to be dynamic. They want to move around. When we put infrastructure in there, that's always a risk. Any of you folks live near Ivy Road on the Maple? Know where Ivy Road is on the Maple River? They put in a new bridge there, and they finished the bridge, I think, in August of 2010. They still had the plywood up from painting the underside of the bridge when the September 2010 flood came through. and it ripped out probably 50 feet on the other side of the bridge. The bridge was no longer connected to the other side. A bridge to nowhere, but they rebuilt the other side. These are always problems we need to deal with. Yeah. By and large, I think that engineering around these rivers is at a very high standard in Minnesota. I've seen around the country highly variable engineering in proximity to rivers, and you guys do pretty well, but certainly there's room for improvement. A lot of people are talking about, can we change culvert sizing to manage flows and things like that, and there are infrastructure issues to think about there. But one of the things I really love about coming back here and working in Minnesota is you guys are having these conversations as constructively as I've seen anywhere across the country. I really appreciate that. And I think you guys should appreciate that. There's a lot of great things going on here. Good conversations being had. Other questions or comments on that kind of the general introduction? Yeah?
Could you talk a little bit about the impact of trees on the landscape and the history of planting trees?
Trees.
Yeah.
Trees have a pretty big impact on the river, and if I go back here, these really low gradient reaches of the river, they don't have a whole lot of stream power. I did actually get capsized a canoe once. I canoed all these rivers many, many times, and we capsized, and I ended up getting pinned against a tree. That was the scariest time of my life. These rivers only lose 40 centimeters per kilometer. That's a little over a foot per half mile. They don't lose a whole lot of gradient as they're going downstream, but there's still a whole lot of power in that river. But the trees really control the river up here. And you can see as these rivers have tried to widen, they're just running up against the tree roots right now. And so you've got tree roots exposed on both sides. In some cases, the river winds and pulls those trees in, and that destabilizes the river locally. Once you get downstream into these really high-powered, high-energy systems in the green here, trees don't have a whole lot of impact. There's trees in the river, but the river's really dominating what's going on. I don't know if there were specific things, Steve, that you were wondering about, but those have been my observations.
During the glacier, there probably weren't too many trees around, and so
Oh, yeah.
today we have a lot of trees, and we also used to have a lot of fires that would control trees too. So I think trees have a pretty big impact on what's happening on the ravines and other places.
They're certainly a very strong stabilizing force. Yep, indeed. By and large, I would say that the riparian areas here in Minnesota are in pretty good shape. I'm saying that relative to a lot of other places that I've worked and been. By and large, you guys have done a great job keeping those in good shape. Okay. Let me get into talking a little bit about what ravines are, and I'm going to try to stay within my time here so we can turn over to Marty next. But a ravine is basically, this is from the LiDAR image, the 1 meter DEM that Minnesota invested quite a bit of money to get really high resolution topographic maps, and it's maybe the best investment Minnesota's ever made. There's an incredible amount of information in there for you to use at the scale of your own field, or for us to use at the scale of the entire Minnesota River Basin. There's an incredible amount of information in these high-resolution maps. A ravine is just this here, a small fluvial network that's connecting these relatively flat uplands to these incised rivers. And here's a look at one ravine. I'll show quite a few other photos of ravines. They are pretty steep areas. I'm distinguishing ravines from gullies mainly by size. These are what I would call gullies. These relatively small things that you could run a tractor over, smooth out. And I distinguish those from rills, these really small things. They're even smaller. So it's just a matter of scale. The ravines are kind of the permanent features in the landscape that are caused by fluvial incisions. So here's a ravine, uplands, These are what we call bluffs. Those are made of all the native material here, the glacial sediments. And then I differentiate those from stream banks, because the stream banks are what the river itself builds. And those erode by different processes, and they have different grain size distributions. So when they erode, they bring in different amounts of sand and silt and things like that. So that's how we distinguish between those. And we've got active floodplains. So that's a little bit of taxonomy. Ravines typically start as just crenulations on bluffs that end up getting more flow accumulating to them. You got more power, so you start cutting through the bluff, and before you know it, you've got a ravine started here. Here's another ravine, a couple of photos from within that. Some of these are really active, some are less active. The heads of some of these are being actively managed. This is one where somebody put up a little dam there, and upstream from there that's filled in, but probably stopped some of the head cutting that's going on there. Some of these have county drain tiles coming directly into them. There's a lot of flow coming into the heads of a lot of these. The vast majority of ravine tips do have drain tiles coming into them. That's something that we'll talk more about. Marty, I'm sure, will address. One point I want to make really clear is that there's a lot of different ravines out there. When I came here 7 years ago, I'd never worked in agricultural landscape before. And so when I heard agricultural ditch, I thought, agricultural ditch is an agricultural ditch. They're all the same, right? Well, you guys know, as I do now, they're all different. Agricultural ditches are all quite different, function differently in terms of the water and sediment and whatnot. Ravines are the same. There are a lot of different kinds of ravines in there, and each of those different types of ravines requires a different management approach. Some of these ravines come directly down to the river. Other ones go across what we're calling terraces here. These are old floodplains. And the LeSueur was at a higher level, thousands of years ago maybe, and some of those come across those terraces. And that has implications for how much it downcuts and how sensitive that ravine is. So of the 74 ravines that we've mapped, 59 of them come across terraces. They don't connect directly to the river. Some are disconnected now from the river, others have been reconnected, sometimes in kind of circuitous routes. This is near the Maple River on Highway 35 there. Here's a really important point, something to be looking for in ravines near your property. This is, again, LiDAR data. Here's one ravine, and I've just made a cross-section through it there from A to A prime, and it's just this nice V-shaped feature. That's what we see in a lot of the ravines in the LeSueur and Blue Earth watersheds. Some other ravines have these things that are called fill terraces. And so this is all stuff that has come from somewhere else and got deposited in there. There aren't a lot of these in the LeSueur watershed. And I've been in a lot of ravines throughout the watershed. I don't see these commonly, but interestingly enough, you just go up into 7 Mile Creek, and every ravine in 7 Mile Creek has some of these fill terraces. And these things are very sensitive, they're highly erodible, and require you to be kind of careful as you're thinking about how you're going to manage the ravine. This is what some of these fill terraces look like at the bottom of these ravines. This would be a steep wall here, steep wall over here, and there's a whole lot of sediment there. Here's another one that's in 7 Mile Creek that now has started a down cut. That's probably about 20, 25 feet that this ravine is cutting down through a fill terrace. Some of these ravines are very active. We've mapped out all of these ravines all throughout the LeSueur watershed. 1938 ravines are in blue, 2006 are in red, so you can see where a lot of places they haven't really changed, and other places new ones have popped up. And new ones continue to pop up. More often than not, those end up being in cases where there's drain tiles coming into the tip and the tip hasn't been properly stabilized. People end up losing land. Another insight, I don't need to tell any of you this, but these are incredibly flashy systems. They don't flow for very long. This is Pat Basfield and Scott Madison, who have really done a lot of great monitoring work in the ravines as well as in the LeSueur watershed. They put in some gauges to show when the ravines were flowing, and what you see is, well, there can be very big events that don't last very long. The concentration of the sediment coming out of the ravines can be very high, but they flow infrequently. And most sediment, 70 to 95% of the sediment in the ravines that we were gauging have come from within the ravine itself, not from the uplands around the ravine, but within the ravine itself. During 2008 and 2009, 95% of the sediment load came in less than a week. So there's only about a week's worth of time where these things are contributing virtually all the sediment they contribute throughout the year. Just a quick example, and this is getting right towards the end of the presentation here. This is the ravine near Highway 90. This is the LeSueur River here. We had an upper sampler and a lower sampler on this in 2008. The upper sampler, there's only 10 tons of sediment that passed through that gauge there. But by the time you get down to the lower end of this ravine, there's 170 tons of sediment that came out. That translates to about 30 pounds per acre at this upper gauge, 3,800 pounds per acre at this lower gauge. It's about 94% of sediment coming out of the ravine itself. They're very sensitive systems. So just a couple of general guidelines, and I think Marty will probably pick up here and give you some other insights into ravine management. Don't destabilize the system. Now, these are very sensitive systems. Some of the best things you can do to not destabilize the system or to maintain the stability is maintain the vegetation and protect the areas of concentrated flow. Make sure these ravine tips don't continue to extend up in your property. Beware of these fill deposits. These old deposits, the ones that we've dated in 7 Mile Creek, we can show that that was once upland soil. All that soil came from the uplands. More than 70 years ago. So it's relatively old sediment. It's been sitting in there until just recently it started to be evacuated. Use caution if you're going to try to remove some of that sediment. And this is important. Let's not create new ones. Let's not create new pools of sediment that are going to have to be dealt with later. I know using ravines as water and sediment detention basins is a popular idea, and I think that has some merit. But we need to be careful that we're not creating a problem down the road by creating dams that are just going to store a bunch of sediment that we're going to have to deal with. So let's be mindful of that. Last point, water management needs to be coordinated, and this is why I really appreciate the SWCDs, MPCA, MDA, and just the general public being out there and willing to come to meetings like this to see how we can do this better at a landscape scale. If you store water in the wrong places and add it to a flood that's coming downstream, you could actually make the problem worse. And so we need to be thinking about this problem in a landscape context, and that's why meetings like this are so important. So with that, I've got a lot of folks that I'm working with that I should thank. There are a number of other folks here doing work. Chris Leonard and Les Everett are here representing the University of Minnesota. A lot of great research going on, and thanks a lot for listening. Take any. Do I have a couple minutes for other questions? 4 minutes, Rick tells me. Question?
About 3 slides back, we have the green gauges.
This one here?
Yeah. Where you sample at the top and then at the bottom. Would you determine how much of that sediment actually came from the mean or the creek you traveling along there?
Right, yeah.
Or how much of it came from the other?
Yep. So it's a great question. And so the question was, could we determine how much of the sediment is actually coming from this ravine versus from the uplands around it or from this ravine itself? And the short answer is that's a hard thing to do. What we saw was that there's just not a whole lot of sediment coming in up here. We had a variety of other techniques we were using to show that upland erosion rates are not that high here. They really, you guys are doing a good job keeping soil on your fields. That's where it belongs and that's where you want it. So basically we took the erosion rate that we knew was coming in from that, applied it to the rest of this area, and said that's how much is probably coming from that area. And the rest of it's coming from this whole incised area. We couldn't differentiate this from this in here, but the numbers are striking. You're going from 10 tons up to 170. It's clear that the vast majority of it comes from within the ravine itself. We've gone through and mapped all the drain tiles. We've mapped there are bluffs within this ravine. We've mapped all those before. And so we know where all those are. They're just very sensitive systems.
In your inspection of ravines, have you looked at the layering or of the glacial materials, the till, the density versus silty, clay, or sandy sand?
Absolutely. So Carrie Jennings, probably some of you know, she was with the Minnesota Geological Survey. She's with the DNR now. She's mapped this entire area. We've been working extensively with her over the last 7 or 8 years. And she's developed some really nice maps of the surface geology as well as the stratigraphy. And that's important. There are several different layers in there, and they all have different amounts of sensitivity.
Any conclusions actually contributing to instability of the soil in the ravines?
By and large, the vegetation is the dominant control. If you maintain the vegetation, that's going to be your dominant control. But certainly the sandier soils are more prone to erosion. These really cohesive clay, silty soils, tills, will hold a little bit stronger. Yeah, Les?
You mentioned the need to coordinate water management. I assume that means the release of water throughout the basin. There's organizations who do that in the Red River Basin, but I don't know that we've got those in the Minnesota River Basin. Would you see any examples?
There isn't one entity, but I think this is one example of getting people together and saying, what's going on in different places, and let's have a conversation about how all this fits together. So I absolutely agree with you. It can and should be more centrally coordinated. But I think the Water Resource Center is doing a good job trying to pull people together to have those conversations at least. I think an important part of all this is that you guys know more about what's going on in your backyard than anyone. And I think that getting information from you and giving you the best information so that you can make the decisions that are right for you is, in a lot of ways, the best thing we can do. But there has to be somebody pulling it all together and saying, in this part of the landscape, this is a better approach. In this part of the landscape, this is a better approach. So.